today is we're looking at how to divide monomials, specifically also looking at what we do when we're in a situation where we have to also divide exponents. And so our first page here is just giving you a few steps to help you in simplifying when we have to divide. And so my advice to you is the first step is to break the numerator into prime numbers, so just like what we've been doing with the factor trees, and making it all into a multiplication line of just all prime numbers. And if you have variables, don't leave them in exponent form. So you want to write out if it's like x squared. X squared means that we're multiplying two x's together, so break down those two x's. Do x times x. Do that in the numerator. Step 2 is telling you to do the same thing in the denominator. And in step 3, basically what you're doing is once you've broken down all of the numbers into primes and all the variables, you've taken them out of exponent form, cross out things that are exactly the same in the numerator and denominator. And once you've done that, we're going to multiply all of the remaining things together. Okay, so let's look at number 1. So that one is simple. I think that you guys might be able to do that even in your head without doing it through these steps, but I just want to show you how to do this. So it might take a little longer, but it's just prepping us to show us how to do the more complex ones. And so let's go through the steps that I gave you. So 24 over 36. So oops, my marker is acting up here. Okay, 24 over 36. So let's break 24 into primes. So we know for sure, if I go over to the side here and do some scratch work, 24 could be, let's see, 8 and 3 maybe. And then we get 2 times 2 times 2, right? Because the 4 is missing the 4 there. So there we go, 2 and 4. Okay, and then 3 we know is already prime, so it just stays like that. So 24 on the top as a product of primes would look like 2 times 2 times 2 times 3. And then if we were to work on 36, let's work on 36 maybe right here. So let's say we have 6 and 6, 3 and 2, 3 and 2. And so 36 I can have 3 times 2 times 3 times 2. Okay, and so now since we have gone and done all of our broken everything into primes, what I can do now is I can start crossing things out like what I'm asking you to do in step 3. Okay, so looking at the tops, let's change the color of the pen here so it's a little easier to see what's going on. So looking at the tops, I have a 2 right here, and I also have a 2 right there, so I can cross that out. I have a 2 right here in this top, and a 2 right there to cross out. I have a 2 here, but there's no more 2's on the bottom, so I can't cross that out anymore. But I end up with a 3 here. I can cross that out. Okay, and so what's left? On the top, I have just this 1, 2, and so I write it again. On the bottom, I have just this 3, so I write it again. And so to simplify this, I get 2 over 3. Okay? So as you see, I've been kind of trying to be slick erasing this on the side here so we have some more room for some scratch work. But on your paper, that shouldn't be a problem. You have lots and lots of space. Okay? So hopefully that made a little sense with the prime stuff. Let's move on to number 2 and let's see how you guys do with number 2. So I have 15 and 20. So let's start with the top. You guys know 15 splits into 5 and 3. Okay, and that's it. Those are both prime numbers. So I end up with 5 times 3. And then on the bottom I have 20, which is 5 times 4. The 5 just comes down again, but the 4 splits into 2 and 2. Okay, so I have 5 times 2 times 2. And so let's cross some stuff out. I'm going to change the color so we're able to see what we're doing. Okay, changing it back to that teal color. Okay, so I have a 5 here on the top. I also have one on the bottom. I have a 3 here, but I have no 3's on the bottom. And then obviously there's no 2's on the top, so that's what I have left over. So I'm just going to keep what I have or multiply what I have left over here. So on the top I just have a 3, so I rewrite it. There we go. And on the bottom I have a 2 and another 2, so 2 times 2 is 4. And I circle that up, and there's my final answer, 3/4. Okay? Alright, now let's get into the good stuff. So 1 and 2, you're like, oh god, I could do that in my head. But 3 and 4 is not, may not be so straightforward. So let's look at 3 and 4. Let's start with 3 first. And so now I've mixed it with numbers and letters, but we're going to treat it the same way. So let's work on factoring out the 16 and then factoring out the 18. So let's go over to the side here. So 16, it's going to turn into 4 and 4. 2, 2, 2, 2. So I end up with here on the top, for the numbers part at least, 2 times 2 times 2 times 2. Okay, I have 1x, so I'm going to multiply that by 1x. And I have 1y, so I'm going to multiply that by 1y. Now I have 18 here on the side, so let's work out 18. Let's do 9 and 2. 9 and 2, we get 3 and 3, and drop down that 2. So my product of primes would look like 3 times 3 times 2. And then I have an x there, so it just goes like that. Okay, and so here we go. I'm going to change the color on us so we can tell what's going on. And here we go. So I have a 2 here, so I can cross that out because there's a 2 on the bottom. And now I have a row of 3 2's, but that's the only 2 I had on the bottom, so I can't do anything with it anymore. So I'm going to skip the 2's because there's nothing else to cancel it out with on the bottom. And so I go x and x, but there's no y, there's no 3's. And so the important thing to know, you guys, is when you're canceling things out, it has to be a top and bottom combination, just like how we had a 2 here and a 2 here. Just because there's 3 2's in the same line, you can't cross them out. It has to be a top and bottom. Okay, and so we're going to multiply everything that's left over. So I have 2 times 2 times 2, which is 8 on the top. And then I have a y still left over, so I have 8y. On the bottom I have 3 times 3 is 9. So answer for this is 8y over 9. Okay, let's look at number 4. And number 4 is going to be interesting here. So I have, let's work on the number part first, 12. And then I have 3, negative 3 at least. And so the bottom part's actually easier to start out with, right? Because negative 3 is already, that's already a prime number already. 3 is already a prime number. And then I have 3 x's, so remember, I don't want to leave them as exponents. I want to actually expand them out. And so the top now, let's work on 12 is 4 and 3, 2 and 2, and 3. Okay. And so I have 2 times 2 times 3, and then look how many x's I have. I have 5 this time. So I have 1, 2, 3, 4, 5. Okay, and so these look like borderline y's there. Okay, now let's cancel some stuff out. Okay, and so let's just change it to that. Here we go. So I have a 2 here, but there's no 2's on the bottom, so unfortunately both of the 2's have to stay. I have a 3 here, and I actually have a 3 right here too. So this negative, we're just going to preserve it as a -1. Okay, so those 3's can cancel out as long as for the negative you preserve it as a -1. I have an x here and an x here. X, 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 and that's it. Okay, so on the top I have 2 times 2 is 4, and then x times x is x squared. And then what else do I have here? On the bottom I have that -1, and that's it. Okay, so all that's left over, if you want to make this even better, is -4x squared. And that would be our final answer for this. Okay, sorry, I don't know why my x's are turning out looking like y's. There we go. Okay, and so there we That's it. That's all we have there. The last thing I want to give you is the last rule of exponent that you need, and that's basically happens when you're dividing two things, okay? So if you're dividing two things and the bases are the same, basically you're subtracting, okay? And so these are the three situations that could happen. So the first one happens when you have the same base or the same big number, but the exponents are different, and let's say the bigger exponent is on the top, then that means that there's no fraction in the end. So all you do is you keep the base and you subtract the exponents, and there's no fraction, okay? Whereas in number 2, the bottom number is bigger, and so that tells us that our final answer is going to have it is going to end up being on the bottom. That's the way you can remember that, okay? So if the bottom exponent is bigger, that means that we're going to have an answer that's a fraction, and that number, whatever it is when we simplify, is going to be on the bottom. So bottom number's bigger, bottom exponent's bigger, bottom answer. And then number 3 is when they're both equal, both of the exponents are equal, and both of your bases are the same, you just get 1. Okay, so here's a few examples. Looking at number 5, we have x to the 8th over x to the 4th, and so they both have the same base number, and they both have different exponents, and so we know it's definitely going to be 1 or 2. Now let's narrow it down. Is the bigger number the top one, or is the bigger exponent the top one or the bottom? It's the top, so it's rule 1, okay? So our final answer is not going to be a fraction. So all you do is, since it's not a fraction, you keep the base, which is x, and then you subtract the exponents, so 8 minus 4, and so we end up with x to the 4th as the final answer, okay? Looking at the second one, let's see. So same situation here, both same base, but I have different exponents, but this time the bigger one is on the bottom, so that tells me I'm going to have a fraction. So it's going to be 1 over, and we keep the base and subtract the exponents, so 5 minus 2, and so we end up with 1 over b to the 3rd. Okay. Our 7th example is just looking at how a problem might look if you end up having things exactly the same. And so even without doing all this subtracting business, what you can tell is, since they're exactly the same, they both cancel out. And remember, when things cancel out, like if I had 2 over 2, you guys know it's 1, right? When things are exactly the same. Same idea here. So they both cancel out, they're exactly the same, so the answer is 1. Okay. This last example, number 8, I just wanted to show you because it's putting two variables in, but you treat it the same way. But the way that you look at them is you look at them separately. Okay, so look at the m's first, and then look at the n's. But they're both going to share the same fraction line. It's just that you're going to look at them separately to help you out. Okay, so looking at the m's, which m is bigger, top or bottom? Bottom, right? So we keep the m right there, and then we subtract. So remember, when there's nothing written, that's really a mystery one. So I have 3 minus 1 for the m's, and then the n's, let's look at the bigger n is on the top, so I leave it on the top. 5 minus 2, okay, and so I end up with n to the 3rd over m squared. Okay, and that's it. So basically you just want to look at wherever the bigger one is, that's where it's going to end up. So the m's, the bigger exponent, was on the bottom, so m's going to end up on the bottom. In looking at the n's, the bigger exponent's on the top, so the n's ended up on the top. Okay, so that's it. Don't forget to take your quiz.